Hi, and welcome to the second session of Chapter 6, Statistical Quality Control, or SQC. In the first session, we overviewed what you will see in this chapter, including the different categories of statistical quality control, and we reviewed the descriptive statistics. So what we are going to see in this video, we'll talk about two categories of quantities that we are interested in quality management. The two categories are variables and attributes. What's the difference between variables and attributes? Variables are the quantities that we are interested in measuring, and we can only measure. So quantities such as the length, weight, diameter, and time. And then attributes are the ones that you can only count. So you cannot measure the percentage or the number of defective items. Instead, you count those items, right? So remember these two categories, variables and attributes. Because these are different in nature, we have to use different types of control charts for each. So for the first category, for variables, again, the ones that you measure, we use X bar charts and R charts. What's the difference? Why do we have two types of charts for this? So X bar charts measure the mean or the central tendency of the observations. And then R charts, so R stands for range, so R charts are used to monitor the variability or dispersion or range of the observations and processes. So in this video, we'll do the first two types of charts, including the X bar charts and R charts. The example that we will use for both types of charts is this one. So let me read this. A quality control inspector at the Cocoa Fizz soft drink company has taken 3 samples with 4 observations, each of the volume of bottles filled. If the standard deviation of the bottling operation is 0.2 ounces, use the below data to develop control charts with limits of 3 standard deviations for the 16-ounce bottling operation. So what you see in this question, there are 3 samples, time 1, time 2, and time 3. So let me actually show that on the next slide. So 3 separate samples. Let's assume these are, for example, Monday, Tuesday, and Wednesday, or perhaps the first day of June, first day of July, and first day of August, or any 3 separate occasions that you did the sampling. So the number of samples is equal to 3, and then within each sample we have 4 observations. So for each of these samples separately, for time 1, time 2, and time 3, we calculate the average. So X1 bar, or the average of observations in sample 1, is just simply the mean of these 4 values, right? It's going to be 15.875, and similarly for sample number 2 and 3 we have these values, okay? So these are the formulas that we use to calculate the CL, or center line, UCL, or the upper control limit, and then LCL, or the lower control limit, for the X bar chart. So this needs a little bit of explanation here. First thing that you should know, and you should not confuse, is the difference between K and N here. So yes, I told you I will give you all the notations in the exam, but I want you to know, I will give you the formulas in the exam, but you have to know the notation. So what is K? K is the number of samples. N is the number of observations within each sample. So in this example, K is equal to 3, N is equal to 4. If you don't know the difference between K and N, and if you write K is equal to 4 and N is equal to 3, pretty much all of your calculations will be incorrect from the beginning to the end, and perhaps the conclusion that you will draw at the end will also be incorrect. So make sure to know the difference. Once again, K is the number of samples, or number of means, number of sample means. So we have 3 samples, so we have 3 sample means. K is equal to 3, N is equal to 4. this number of observations per sample is also known as the sample size. So sample size here is equal to 4, not 3. So how do we calculate CL? Now that you know what x1 bar, x2 bar, and x3 bar is, so CL, or the center line, or x double bar, which is basically x bar bar, so it's the average of our averages. That's x1 bar plus x2 bar plus x3 bar divided by k, or the number of samples, which is 3. So 15.92 is going to be my center line. And then the formulas for the upper control limit and the lower control limit for the x bar chart. So for both of them, I need to know the value of x double bar, which we just calculated. And then we need to know the value of z, the number of standard deviations. How did I get that? If you go to the previous slide, somewhere it was mentioned that with limits of 3 standard deviations, so number of standard deviations is z, which is 3 in this example, and then the value of standard deviation of the operation is 0.2 ounces. So this is sigma. 0.2 is what you need to consider as sigma, and then you have the square root of n. N, remember, was equal to 4, so 0.2 divided by the square root of n, that's going to give us our sigma of x bar, which we need in the UCL and LCL formula. So one more time, if you plug in the values that we calculate, x double bar plus z equals 3 plus sigma 0.2 divided by the square root of n, and we will have these values for UCL, LCL, and CL. So that's the first phase of the calculations. This is how we calculate these thresholds or control limits. Next, we have to graph our control chart. So on the x-axis, we always have samples, and on the y-axis for this chart, we are doing x bar chart, so we have the actual volume of bottles in ounces. So samples 1, 2, and 3. Next, you do the LCL line, 15.62, CL center line, 15.92, and UCL, 16.22. You don't have to do that in Excel. I mean, you can do that on a piece of paper or Excel, whichever you're more comfortable with. So next, you plot the value that you have for the first sample. So this is x1 bar, or the mean of the first sample. This is x2 bar, and this is x3 bar. Remember, you have to connect these dots. If you don't connect these dots, your x bar chart will be meaningless. So x1 bar, x2 bar, and x3 bar, you have to see the location of these dots with respect to the UCL and LCL lines. So if everything is between the lower and the upper control limit, which is the case here, then you will draw this conclusion. Sample mean of the bottling operation at the Cocoa Fizz Company is in statistical control. Remember, these conclusions of control charts are very, very important, and they're going to be very similar for the other types of charts. So here we're doing an X bar chart, so we wrote sample mean, and always is or is not in statistical control. So again, because everything was in between the two lines, here we wrote sample mean is in statistical control. For the next type of charts, for the R chart, first we have to calculate the values of R1, R2, and R3, which is the range of each of those samples. So how did I calculate the range of samples 1, 2, and 3? If you go back to the example that we had. So I purposely left this row blank. Oops. So for sample 1, the difference between the highest and the lowest, so the lowest is 15.8, either this one or this one. The highest is 16.0. So the difference is simply 0.2. Here, 15.8 is the lowest, 16.1 is the highest, so 0.3. And then again 0.2 here. So the values that we have for our chart, so let me skip these. So that's the values that we calculated there, right? Next, the formulas that we need for CL, UCL, and LCL. So CL is simply R bar, which is the average of these three numbers, so divided by K, 3, that's 0.233. Then for the UCL and LCL, it's actually very easy. We just need to use this formula, D4 times R bar and D3 times R bar. So what is R bar? We just calculated that. D3 and D4, we need to look up the values of D3 and D4 from this table, which is a statistical table similar to the tables that you had for I don't know, like normal distribution and t-distribution in your stats class. So you need to first find your sample size n, which here is equal to 4. One more time, here k was 3, n was equal to 4. So because n is equal to 4, d3 is going to be 0 and d4 is 2.28. So you plug in the values of d3 and d4, that's d3, that's d4. You calculate the values of UCL and LCL. We already calculated the CL. So on the next slide, this time we have samples on the x-axis and volume ranges on the y-axis. So samples 1, 2, and 3, LCL is 0, CL is 0.233, and UCL is 0.53. So of course we need to plot the values of R1, R2, and R3 here. Similarly, you connect the dots, and again everything is between the LCL and UCL. So your conclusion here will be that the sample range of the Bolling operation is in statistical control. So this time the subject of the sentence changed from sample mean to sample range, but the rest of the structure is exactly the same. So sample range is indeed in statistical control. In the next class, not here, we'll talk about the other two types of charts which are used for attributes. So P charts and C charts are used for attributes, not for variables. So at the end, you have to complete a quiz, an online quiz. You know, this quiz has to be completed on Tuesday the 20th, okay? So no late quizzes will be accepted here. You need to get at least 2 out of 8 correct for the attendance point, and then if you get 8 out of 8 correct, you will get the regular half of bonus points. So I'll just show you the questions here, and then you will see you need to answer on Moodle. So question number 1, of course you can pause. Number 2, three, 4, 5, 6, 7, and finally question number 8. Good luck with the quiz. And see you in class.